So there are two common ways that we can find the derivative of x to the power of x. And the first way is to use logarithmic differentiation. So let's let y equal x to the power of x, and then take the natural log of both sides. So we'll have that the natural log of y is equal to the natural log of x to the power of x. And one of our properties of logs is that we can move our exponent to the front of the log. So we can change it from being an exponent to being a coefficient. So what we'll have here is that the natural log of y is equal to x times the natural log of x. We just moved this exponent out front. So now we're ready to start taking the derivative by taking the derivative with respect to x of both sides of our equation here. So we're going to have the derivative with respect to x of the natural log of y, and then this will be equal to the derivative with respect to x of x times the natural log of x. So then let's continue with our next step up here. To take the derivative of the natural log of y, we're going to have to use implicit differentiation techniques here because we're taking a derivative with respect to x and our function is defined with y. So we're going to have to use implicit differentiation, at least for this side of the equation. So this is going to be equal to the derivative of the natural log of y, which is going to be 1 over y, and then multiplied by dy dx, because we're taking the derivative of y with respect to x. And then this is going to be equal to the derivative of x times the natural log of x. Now here we're going to need to use the product rule for derivatives. And remember, the product rule says that if we have two functions, f of x and g of x, and they are multiplied together, and we want to know their derivative, it's going to be equal to the first function, f of x, times the derivative of the second function, g of x, plus g of x times the derivative of f of x. And so that's what we're going to do for x times the natural log of x. We're going to have x times the derivative of the natural log of x, which would be 1 over x. And then we're going to add this to the natural log of x times the derivative of x, which in this case is just 1. So now we can simplify, and this is going to be equal to 1 over y times dy dx. And then over here we're going to have 1, because x times 1 over x will just be 1, and then plus the natural log of x. Now we want to multiply both sides by y so that we can cancel out this 1 over y and just be left with dy dx. So if we multiply both sides by y, we will have dy dx is equal to y times 1 plus natural log of x. Now we're almost done. All we have to do now is redefine this y to be in terms of x. And if you remember, right at the beginning, we let y equal x to the power of x, so we can actually just plug x to the power of x right back into our final answer here. So we will have that dy dx is equal to x to the power of x times 1 plus the natural log of x. And that is going to be the final answer, or our derivative of x to the power of x, at least by using logarithmic differentiation. But now let's find it using a different method. So once again, we're going to start off by letting y equal x to the power of x. And now this time we are going to use the properties that we know for e and the natural log of x. So if we change our function here and we write y equals e to the natural log of x to the power of x, that is an equivalent statement to our original statement here. Because remember, when you have e to the natural log of x, e and the natural log will cancel out, and you'll actually just be left with x. So in this case, these two would cancel out, and we would be left with x to the power of x. But we actually don't want to cancel them out, right? We added them in so that we can take the derivative of this function. So now, just like we did in our previous method, we can use the properties of logs to move this x and the exponent out front of the natural log. So we will have that y equals e to x times the natural log of x. So now we're ready to take the derivative. We will have that dy dx is going to be equal to the derivative of e to the power of x times the natural log of x. And you'll notice here that we're going to have a chain rule. So we'll start by taking the derivative of our outer function, which is going to be e and then its power, and then we'll multiply by the derivative of the inner function, which is going to be this x times the natural log of x. Now remember, taking the derivative of e to the x just gives you back e to the x, so the first part is actually pretty easy. We're just going to have e to the power of x times the natural log of x, and then we're going to be multiplying by the derivative of that power, x times the natural log of x. And we actually did this already. This is where our product rule came into play, but we'll do it again. So we're going to have our first function, x, times the derivative of the natural log of x, so that will be 1 over x, and then we're going to add the natural log of x times the derivative of x, which again is just 1. So now we can simplify, and we will be able to find our derivative here pretty easily. So this will be equal to e, and I'm actually going to move this x back up as an exponent using our properties of logs. So we'll have e to the natural log of x to the power of x, and then that's going to be multiplied by x times 1 over x, which is just 1 plus the natural log of x. And now we can simplify this term by canceling out e and the natural log to go back to our original form from the beginning. So we will have that this is equal to x to the power of x times 1 plus the natural log of x. And that is our derivative dy dx in this case. And so that's our final answer, and you'll notice we got the same answer from this method as we got from our first method. So whether you use logarithmic differentiation or e and the natural log, you are going to get the same derivative. And that's it. I hope you found this video to be helpful. If you enjoyed this video and you want to see some other math-related content, feel free to check out my channel where I have some other videos on topics in calculus and other math topics too. But that's all I have for now, so I will see you next time.